Good morning, students. This is Androhi Reddy, working as Assistant Professor in Department of Mechanical Engineering. In this session, we are discussing about the problems on the crankshaft. In the last classes, we have discussed about the derivation of the crankshaft. The design process of the crankshaft. Once we get to revise the design process of the crankshaft. Okay. So in this crankshaft, there are two types of crankshafts will be there. One is the side crankshaft, another one is center crankshaft. Side crankshaft is also known as overhung crankshaft. Center crankshaft. In the center crankshaft, the load is applied directly to the crankshaft, and also the efficiency will also be decreased compared to the overhung crankshaft. Overhung is nothing but with the effect of the torsional momentum or different types of angles, and we will find out the overhang crankshaft. Okay, in now we are seeing the design process of the overhang crankshaft. Design of overhang crankshaft when the crank is at dead center. Dead center is nothing but we can take a top dead center and also the bottom dead center. Okay, the forces acting on the crankshaft. First one, force on piston Fp, weight of flywheel W, horizontal load due to belt tensions P1 plus P2. If you see the images, these are the crankshaft which are applying on this cranking rod. Okay, here this is the crankshaft which we are taking up. We are taking with the help of the two reactions. One is vertical reaction and another one is horizontal reaction. So with the help of the different diameter, length of the elements. Okay. Next in this image also we are taking the tracing point of a vertical reactions like R1 dash and also R2 dash in the vertical reactions. Also next we are finding the horizontal reactions of the crankshaft. Next we are taking the support reactions of the crankshaft. Support reactions is nothing but the forces on the piston Fp is equal to 5 by 4 d square into P max. Considering forces Fp, taking moment of forces bearing 2. Okay, from the bearing 2 reactions, we are taking the moment reactions. It is nothing but Fp into B plus C is equal to R1 dash into C. We know that how we are taking the reactions like that on the same we are taking the reaction in vertical directions. R1B is equal to Fp into B plus C by C. Similarly, taking moment of forces about the bearing 1. Fp into B is equal to R2 dash into B plus into C. Like that you will find out the R2 dash B. Considering forces W taking moment of forces about 1 and 2. You will find out the R2 dash and also R1 dash in the vertical reactions and also the horizontal reactions with the help of the bearing pulleys in the horizontal reactions like P1 plus P2. Because horizontally we are applying the crankshaft load, that's why we are taking the R2 dash is equal to P1 plus P2. Next, various parts of overhang crankshaft. Various parts of overhang crankshaft is nothing but design of crank pin. Design of crank pin is nothing but the bending moment at bearing 1 is given by PB is equal to Fp by Lc into DC, where Fp is equal to forces acting on the pin, Lc is nothing but length of crank pin, D diameter of the crank pin, and PB is nothing but bearing pressure of the crank pin. We will find out the L by D ratio of the crank pin is usually 0.6 to 1.5 of the bearing pressure. You will find out the length and diameter of the crank pin. Like that you will find out the maximum bending moment of the pressure which we are applying is nothing but Fp into Lc by 2. Okay, next you will find out the suction modulus of the crank pin and also bending stress of the crank pin sigma p is equal to M by Z. Next, design of bearing. Design of bearing is nothing but these bearings will be induced in different process like MB is equal to Fp into 0.75 Lc plus T plus L 0.5 L1. Here L1 is nothing but the length of the bearing, and also we can take it as L1 is equal to 1.5 dc to 2 dc. Okay. Next, you find out the bearing pressure which you are taking. PB is equal to R1 by L1 into D1. R1 is nothing but resultant reaction at bearing at position 1. Reaction bearing at the bearing 1. Okay. And that you find out the design of the crank web. Crank web is nothing but with the help of the supportive reactions, the web part will be fixed in the IC engine. The crank web is subjected to an eccentric load Fp with the two types of stresses is nothing but direct compressive stress and also bending stress. Direct compressive stress is nothing but sigma dc is equal to Fp by W into T. W is nothing but 1.14 dc. W is equal to width of the T thickness of paper. Like that, you will find out the bending moment at the central plane. Mb is equal to Fp into 0.75 Lc plus T by 2. Since z is equal to 1 by 6 Wt square in the rectangular section modulus, then total compressive stress sigma C is equal to sigma direct compressive stress plus bending stress. Next, design of shaft under flywheel. The central plane of shaft under the flywheel is subjected to maximum bending moment. The maximum bending moment is given by Mb into V is equal to Fp into B plus C1 in minus R1 V plus R1 dash V into C1. Like that, you find out the horizontal reactions. Okay, resultant bending moment is calculated and shaft diameter is found. Resultant bending moment. Resultant bending moment is MB. MB is equal to, we will find out the both x square plus y squared. Then M moment of inertia is I is equal to pi by 4, pi by 64 into ts power 4 and y is equal to ts by 2. Then sigma b is equal to mb into y by I. Thus the shaft diameter ts can be calculated as with the help of the given sections. Next, you should find out the crank at the angle of a maximum torque. Maximum torque is nothing but you will take with the help of the layout of the IC engines. Layout of the IC engines is nothing but will take the piston method, and with the help of the piston, the power is transmitted to the connecting rod, and connecting rod is transmitted to the crankshaft. Okay, FP is nothing but forces of piston acting on the piston pin. Okay, it depends upon the connecting rod which they are related to the motion of perpendicular of the motion. Then crank is equal to nothing but OA. Like that, you will find out the different types of forces acting on the crank. The torque is maximum when tangential component of force on crank pin is maximum. Then theta is equal to 25 degree to 40 degree. Let Fp is equal to force acting on piston due to gas pressure 5 by 4 T square into P. Fq is equal to thrust on connecting rod. Ft is nothing but tangential force on crank pin. Fr is nothing but radial force on the crank pin. Fq is nothing but Fp by cos phi. Ft is nothing but Fq into sin theta plus phi. Like that, you will find out the assumptions. It is nothing but the engine is vertical and the belt drive is horizontal and the crankshaft is simply supported on the bearings 1 and 2. Bearing reactions forces in vertical plane. Reactions of radial force CFR. Taking moment of force about the bearing 2. R1 dash is equal to Fr into B plus C by C. Like that, you will find out the R2 dash with the help of the vertical plane and also horizontal plane. Like that, you will find out the design of the crank pin and design of the crank web. Design of the crank web. In this session, we are discussing about the problem on the crankshaft. Okay, first we shall read the problem. Design a side crankshaft for 500 mm into 600 mm gas engine. The weight of the flywheel is 80 kilonewton and the explosion pressure is 2.5 megapascal. The gas pressure at the maximum torque is 0.9 megapascal when the crank is 30 degree from the inner dead center. Okay, the connecting rod is 4-5 times the crank radius. What they had told, the design is side crankshaft for 500 mm into 600 mm gas engine. They have given the length. The weight of the flywheel is 80 kilometer and the explosion pressure, maximum pressure is 2.5 megapascal. The gas pressure at the maximum torque is 0.9 megapascal. When the crank, the theta is equal to 30 degrees at the inner dead center connected rod. Okay, this is the given data. It is nothing but a cylinder bore. Okay, stroke and length. Bore and length they had given. Cylinder bore D is equal to 500 mm. Stroke length L is equal to 600 mm. Then what is the crank radius? Crank radius is nothing but capital L by 2. Means length by 2. 600 by 2, we can take it as 300. It is nothing but crank radius. Okay. Next, flywheel weight. Flywheel weight W is equal to 80 kilonewton. We can write it as 80 into 10 to the power of 3 Newton. Maximum pressure P is equal to 2.5 megapascal. 1 megapascal is equal to 1 Newton per mm square. That's why we can write 2.5 Newton per mm square. Next, pressure at the instant where maximum torque occurs, P dash is equal to 0.9 megapascal. Okay, then P dash is equal to 0.1 Newton per mm square. Crank angle at which maximum torque occurs, theta is equal to 30 degrees. Next, ratio L by R means L by D ratio. Okay, is 4.5. First, you should find out the design of crankshaft when the crank is at dead center. How you will find out with the help of the reactions and also the load or force of the piston. Okay. First, we should find out the force of the piston. 5 by 4 d square into p. 5 by 4 d capital D is nothing but 500. P maximum pressure 2.5. Substitute the values, you will get 491 into 10 cube Newton. Next, first one you should find out the design of crank pin. Let D naught is equal to diameter of crank pin. LC is equal to length of crank pin. LC we can write from the given data. From the data book we can take it as 0.8 DC. Next, what is the formula force of the piston of the crank pin? FC is equal to DC into LC into PB. Okay. D is nothing but F is nothing but we have find out 491 into 10 cube. We don't know the diameter of the crank pin. Length of the crank pin is nothing but 0.8 DC into 10. Assume bearing pressure PB is nothing but 10 Newton per mm square. 10 Newton per mm square. Then the DC is nothing but 491 into 10 cube, 491 into 10 cube by 0.8 into 10. 0.8 into 248 is equal to 198.4 mm. Next, bending moment at the crank pin. M is equal to formula bending moment 3 by 4 into Fp into LC. Substitute the values, you will get the bending moment value. Okay, next you should find out the section modulus. Section modulus is nothing but 5 by 32 dc cube is equal to 5 by 32 to 48 cube. DC you have find out in the upper section. Then you substitute the section modulus. You will get the section modulus value. Now you should find out the bending stress. Bending stress sigma is equal to sigma b is equal to m by c. Substitute the values, you will get the bending stress 48.79 Newton per mm square. Since the induced stress is less than the permissible stress of 60 Newton per mm square, therefore the design of crank pin is safer. Means always the permissible stress for all IC engines is nothing but 60. The bending stress should be less than the 60. So that's why we can take it as the design process of crank pin is safer. You can take the diameters and the length of that crank pin also. Okay. Next, you should design the design of bearing. How you will design of the bearing? Let D1 is nothing but diameter of the bearing 1. Thickness of the crank web. Thickness of the crank web is nothing but T is equal to 0.6 into DC. 0.6 into DC. DC means crank pin, diameter of crank pin. We have find out what is the value of diameter of the crank pin to 48. Substitute the value in the thickness of the crank web. You will get 149 mm. Next, length of the bearing. Length of the bearing is nothing but we can write it as L1. L1 is equal to, from the data book, we can take 1.7 into DC. Substitute the values, you will get the length of the bearing. Okay, like that you can find out the bending moment at the center of the bearing. Bending moment of the center of the bearing formula, M is equal to F into 0.75 into L1 plus T1 plus 0.5 L1. Okay, substitute the values, you will get the M value. Now, but bending moment M is equal to formula pi by 32 D1 cube into sigma B. Next, pi by 32 D1 is equal to M value, you will get the D1 value, means diameter of the crank bearing, diameter of the bearing. Okay, you will get the diameter of the bearing is 349 mm. Okay, next you should find out the design of crank web. How you find out the crank web? W is equal to width of crank web in mm. Bending moment of crank web M is equal to Fp into 0.75 L1 plus 0.5 T1. Substitute all the values, you will get the bending moment on the crank web 109.64 into 10 to the power of 6 Newton per mm. Next, section modulus for rectangular sections. Okay, means rectangular section modulus is 1 by 6 into W T square. Here we know that the T value. Thickness of the crank, thickness of the bearing, we know the T value. Substitute in the section modulus, you will get the Z value. Okay, that is nothing but 3700.167 WLQ. We don't know the W value. Next, bending stress. Bending stress is nothing but sigma B is equal to M by Z. Okay, next, substitute all the values, you will get the sigma B. Next, direct compressive stress. Direct compressive stress is nothing but we can take it as sigma D. Sigma D is equal to formula Fp by W into T. Okay, Fp into W by W into T. Now you will substitute all the values, you will get the sigma D is equal to 3.29 into 10 cube by W. Now you should find out the total stress of the crank web. Total stress of the crank web is nothing but sigma S. Sigma S is equal to sigma A plus sigma D. Okay, crank web and also the direct compressive stress. You find out the sigma D of the total stress 3292 32.92 into 10 cube by W. Next, the total stress should not exceed the permissible limit of 60 megapascal or 60 megapascal. Then you write the sigma T value. 60 is equal to 32.92 into 10 cube by W. You will get the W value as 549 mm. Okay. Next, design of shaft under the flywheel. Let ds is equal to diameter of the shaft under the flywheel. Assume length of the flywheel L is equal to 250 mm and L1 is equal to L2 is equal to 200 mm. L1 is equal to 200 mm. The distance between HB is equal to 250 plus L1 by 2 plus L2 by 2 plus clearance. That is equal to H is equal to 50 plus 200 by 2 plus 200 by 2 plus 20. Then B is equal to 470 mm. And A is equal to 0.75 LC plus T plus 0.5 L1. Next, A is equal to 509 mm. Horizontal reactions at bearing 1. H1 is equal to Fp into A plus B by B. Fp. Fp is nothing but we can take it as 491 into 10 cube into substitute all the values, we will get H1. H1 is equal to 1022.7425 into 10 cube. Next, you can take it as horizontal reactions at bearing 2. Horizontal reactions at bearing 2 is nothing but H2. H2 is equal to Fp into A by B. You will find out the H2 value. H2 value. Assuming B1 is equal to B2 is equal to B by 2. The vertical reactions at a bearing 1. The vertical reactions at bearing 1 is nothing but B1 is equal to W B1 by B. Next, we can take it as W1 into B1, we can take it as B by 2 by B. Means B cancel, you will get the W by 2. Next, W is nothing but 80 into 10 cube by 2. Also, you will get cancel, then you will get B1 is equal to 40 into 10 cube Newton. The vertical reactions at bearing 2, B2 is equal to W B2 by B. The same like that only formula, you will get V2 also 40 into 10 cube Newton. Since there is no tension, the horizontal reaction due to the belt is neglected. The horizontal bearing moment at the flywheel due to the piston gas load M1 is equal to Fp into A plus B2 minus H1 B2. Okay, these are all the formulas which we can take them from the data book only. Okay, substitute the M1 is equal to Fp into A plus B by 2. Okay. M1 is equal to Fp into A plus B2 minus H1 B2. Then Fp is nothing but substitute all the values. Fp we find out that 491. Fp they had given us 491 into 10 cube. A is nothing but 509 plus B2 is nothing but 470 by 2 minus H1 into B2 is nothing but 1022.7. You will get the M1. These are all the horizontal reactions which we are taken. Okay, since there is no belt pulley, there will be no horizontal reaction due to the belt pulley. That is M2 is equal to 0. Total horizontal bending moment MH is equal to M1 plus M2. The vertical bending moment due to the flywheel weight MB is equal to WB1 B2 by B. Okay, next W into B into B. These are all the formulas which we can take. Resultant bending moment. Resultant bending moment is nothing but MR is equal to MH whole square plus MB square. MR is equal to substitute all the values, so we get the MR resultant bending momentum force. Next, bending momentum MR is equal to 5 by 32 into D3 cube into dB. You substitute all the values, so you get the bending moment. Okay, up to now, we will find out, we will check once. First, this is the given question which for the crankshaft. Design a side crankshaft for 500 mm into 600 mm gas engine. The weight of the flywheel is 80 kilonewton and the explosion pressure is 2.5 megapascal. The gas pressure at the maximum torque is 0.9 megapascal when the crank is 30 degrees from the inner dead center. The connecting rod is 4.5 times the crank radius. Okay, given that the given data is nothing but cylinder bore D is equal to 500 mm, stroke length L 600 mm. You calculate the crank radius, small r is equal to L by 2. You will get the crank radius. Flywheel weight W is equal to 80 into 10 cube Newton. Maximum pressure P is equal to 2.5 Newton per mm square. Next, pressure at the instant where maximum torque occurs P dash is equal to 0.9 megapascal. It is nothing but 0.9 Newton per mm square. Next, crank angle at which maximum torque occurs. Angle theta is equal to 30 degree. Ratio L by R is equal to 4.5. Design of crankshaft. When the crank is at its center, load Fp is equal to 5 by 4 d square into P. You substitute all the values, you will get the force on the piston. Next, you should find out the design of the crank pin. Design of the crank pin is nothing but let DC the diameter of crank pin, LC length of the crank pin, L you can write it as 0.8 into DC. Force of the piston. Force of the piston you can take it as DC into LC into PB. Okay, you will calculate the diameter of the crank pin. Okay, next bending moment of the crank pin. M is equal to 3 by 4 into Fp into LC. You will calculate the bending moment. Next, section modulus. Section modulus is nothing but Z. That is equal to pi by 32 into dc cube. You will get the bending stress sigma is equal to M by Z. Where it is less than D60, the design process safe. After that, you can find out the design of bearing. Design of bearing is nothing but let D1 is equal to diameter of the bearing 1. Thickness of the crank rod T is equal to 0.6 into DC. You will calculate the T. Next, length of the bearing L1. Length of the bearing L1 is equal to 1.7 into DC. You will calculate the length of the bearing. Like that, you will calculate the bending moment at the center of the bearing. Okay, you will get the diameters. Next, you should find out the design of crank web. Design of crank web is nothing but let W is equal to width of the crank web in mm. Bending moment on the crank web M is equal to Fp into 0.75 Lc plus 0.5 T. You will calculate section modulus Z is equal to 1 by 6 into W T square. Z is equal to 1, you will find out the 3700.167 W. Next, bending stress. Bending stress is nothing but sigma B is equal to M by Z. We will calculate the bending stress. Next, direct compressive stress. Direct compressive stress is nothing but sigma D is equal to Fp into W by T. Sigma D is equal to 3.29 into 10 cube by W. Like that, you will find out the total stresses induced in the crank wheel.